Welcome back. Domain-3 architecture and design. In this video, we're going to see Domain-3 part 2. Given a scenario, implement secure network architecture and concept. Reliable network security depends on a solid foundation. The foundation is the network architecture. Network architecture is a physical structure of your network. The division of segments, the mean of isolation and traffic control, whether or not remote access is allowed, the means of secure remote connection, and the placement of sensor and filters. So in this video we will discuss more about the concept of network architecture. Security network architecture concepts. So we are going to see that one by one. Zone topologies, segmentation isolations, security devices, IDs and IPs, tunneling VPN, software defined network, honeypots, honeynets. So let's go for the topic. Security zone and topologies. A network zone is an area of network design for a specific purpose, such as internal use or external use. Network zones are logical and are physical divisions or segment of a LAN that allow for supplementary layers of security and control. Each security zone is an area of network that has single defined level of security. The security may focus on encoding authorized access, preventing access, protecting and confidentiality and integrity, or limiting traffic flow. So different security zone usually host different types of resource with different level of sensitivity. Zones are often designed and isolated through the use of unique IP subnet and firewall. Another term of network zone is network topology. There are many types of network zone we will see in this video. The secure zone, for example, the secure zones, these are the most sensitive systems that mission critical data. The general work zone, these are the standard workstations and servers with typical business data and functionality. Low security zone, these are computers and network segments and systems that have no highly sensitive information and the breach of these systems and would have minimal impact. And types: DMZ, Extranet, Intranet, wireless, cast. So we will see one by one. DMZ. So DMZ is a demilitarized zone, is a special purpose subnet. A network consists of networking computer and host. So often large network are logically and physically subdivided into smaller interconnected networks. These smaller networks are known as subnets. Subnets are usually fairly generic, but somehow special users and or configuration. A DMZ is an area of network that is designed specifically for low trust user to access specific systems, such as a public access, a web server. If the DMZ is compromised, the private LAN is not necessarily affected or compromised. Access to a DMZ is usually controlled or restricted by a firewall and router system. DMZ can act as a buffer network between public untrusted internet and private trusted LAN. This implementation is known as screened subnet. It is deployed by placing the DMZ subnet between two firewalls, where one firewall leads to the internet and other to the private LAN. You can see in the picture, DMZ can also be deployed through the use of multi-home firewall, the perimeter firewalls and the internal firewall, one on the internet, one on the private LAN, and one to the DMZ. So you can also just Google it, that how the DMZs works. You get more information about that. So DMZs gives an organization that ability to offer information services such as web browsing, FTP, and email to both the public and internal clients without compromise the security of private LAN. A typical scenario where the DMS would be deployed is where an organization wants to offer resources such as web server, email server, or file server to the general public. Extranet, Intranet. So extranet is privately controlled network segment or subnet that function as a DMZ for business-to-business transaction. It allows an organization to offer specialized service to business partner, supplier, distributor, or customers. Extranet are based on TCP/IP and often use the common Internet Information Service such as web browsings, FTP, and email. Extranet are not accessible to the general public. They often require outside entities to connect using a VPN. These restrict unauthorized access and ensure that all communication with the extranet are secure. Another important security concerns with the extranet is the companies that are partnered today may be competitor tomorrow. Thus, you should never place data into extranet that you are unwilling to let a future competitor have access to. A common scenario for use of extranet is when an organization needs to grant resource access to a business partner or external supplier. These allow the external entity to access the offered resource without exposing those resources to the open intranet and doesn't allow the external entity access into the private LAN. Intranet. An intranet is a private network or private LAN. This term was coined in the 1990s when there was a distinction between traditional LAN and those adopting the internet technologies such as TCP/IP protocol, web service, and email. Now the most network use this technology. The term intranet is no longer distinct from LAN. All organizations that have a network have an intranet. Thus, any scenario involving private LAN is also an intranet. Wireless segmentations. Separate wireless access on an internal network, creating a buffer between wireless and wired networks. Separating guest wireless access from internal networks often allows only an internet access control by 801.1x port based access controls. MAC filtering. So here the MAC filtering is a restriction access based on the device's NIC address as known as MAC. So MAC a media access control of a device is a NEQ identifier assigned to a network interface control for a communications at the data link layer of your network segments. So we will talk about this. So how does it work? So how the MAC spoofs happen? So everything we will talk about in the latter. We already discussed this in the previous video. If you guys missed that video, you can watch this. So security device and placement. Security device placements. Where should security device be on a corporate networks? There's a list of tools: a firewall, UTM, IDS, IPS, a VPN, proxies, load balancer, SIEM, log collection is a monitoring tool. So DDoS. So we will see one by one. So where the security tool will be placed on the corporate environment. So in the firewall proxy, IDS, IPS, UTM. So packet filter, proxy filter, stateful packet inspection. The placement of location of your firewall should be at any transition between network segment where there is any difference in a risk, sensitivity, security, value, function, or purpose. It is standard security practice to deploy deploy a hardware security firewall between an internal network and the internet, as well as between the internet, a DMZ or extranet, as you can see in the picture here, the bottom right side. So a software firewall are also commonly deployed on every host system, both server and clients throughout the organizational network. It may also be worth considering implementing firewall between departments, satellite office, VPNs, and even different buildings of floor. So normally the filters, a packet filter or proxy firewalls, meaning the filters, a filter is used to recognize or match an event, address, activity, content, or keywords and trigger a response. In most cases, a filter is used to block or prevent unwanted activities or data exchanges. The most common example of a filtering tool is a firewall. So a filter should be located in line along any communication path where control of data communication is necessary. So keep in mind that filters cannot inspect encrypted traffic. So filter of such a traffic must be done just before encryption or just after decryption. So proxies are the placement or location of proxy should be between source or origin device and the destination system. The location of a transparent proxy must be along the routed path between source and destination, whereas a non-transparent proxy can be located along an alternate or indirect routed path, since source system will direct traffic to the proxy themselves. So the load balancer, you can see here the previous slide. So load balancer, the load balancer, it should be located in front of a group of servers, often known as a cluster, which all support the same resource. The purpose of the load balancer is to distribute the workload of connections requests among the members of the cluster group, so they determine its locations. A load balancer is placed between requesting client and the cluster or group of server hosting a resource. So same is a log collection correlation. So there's a lot of tools around, like examples. One of the best tool. So you can also Google it how does Splunk does work. So everything you can get more information. So this correlation engine is a type of analyze system that reviews the content of log files or live events. It is programmed to recognize related events, sequentially occurrence, and interdependent activity patterns in order to detect suspicious or violating events. So even though a correlation engine's ability to aggregate and analyze systems logs using fuzzy logic and predictive analytics, it may be able to detect a problem or potential problem long before a human administrator would have taken notice. A correlation engine doesn't need to be inline on the network or installed directly onto monitor system. It must have access to the recorded logs or live activity stream in order to perform its analysis. This could allow it to operate on or near a data warehouse or centralized logging server or of a switch span ports. And then DDoS mitigations. So DDoS mitigation is a software solution, hardware device or cloud service that attempt to filter or block traffic related to DOS attack. So as we earlier talk about this, the previous video we were talk about this, the threat attacks, vulnerabilities. If you guys missed that, so you can watch that previous video, the Domain-1 videos. So a DDoS mitigator will attempt to differentiate legitimate packets from malicious packet. Benign traffic will be sent toward its destinations, whereas abusive traffic will be discarded. low-end DDoS mitigator may be called flood guards. Flood guarding is often a feature of firewall. However, such a solution only changes the focus of the DDoS attack rather than eliminate it. A low-level DDoS mitigate or flood guard solution will prevent the malicious traffic from reaching the target server. But the filtering systems may itself be overloaded. This can result in DDoS even still being able to cut off communication for the network, even when the targeted server is not itself harmed in the process. Commercial grade DDoS solutions, especially those based on the cloud service, operate differently. Instead of simply filtering traffic on the spot, they reroute traffic to the cloud provider core filtering network. The cloud-based DDoS mitigator will often use a load balancer in front of 10,000 virtual machines in order to dilute and distribute the traffic for analysis and filtering. All garbage packet are discarded and legitimate traffic is routed back to the target network. Okay, so a DDoS mitigator should be positioned inline along the pathway into the intranet, DMZ and extranet from the internet. So these provide DDoS mitigators with the ability to filter all traffic from external attack source before it reaches servers on the network as a whole. So we will move on next slide. IPs and IDs. So this is a picture. We talk about this. The topic we already talked about. The sensor collected logs needs network based reacts to detect events, traffic outside of normal bounds, signatures, behavior, heuristic. So you can see the pictures of where the needs an IDs or IPs placed between the firewall and router and in the corporate environment. So let's move on next topic. Segregations and segmentations isolation. So dividing a network into zone based on the business or security need. Example, accounting on different network segment from a manufacturing. So a network segments involves controlling traffic among network devices. Complete or physical network segmentations occurs when a network is isolated from all outside communications, so transaction can only occur between device within the segment network. Logical network segment can be imposed with switch using VLANs or through other traffic control means, including MAC addresses, IP addresses, or physical ports, or TCP or UDP ports, or protocol or application filter, or routing, access control management. So this kind of thing. So the logic VLAN, it includes. So network segment can be used to isolate static environment in order to prevent change exploit from reaching them. The security layer. A security layer exists where devices with different level of classifications or sensitivity are grouped together and isolated from other group with different security levels. The isolations can be absolute or one directional. For example, a lower level may not be able to initiate communication with the higher level, but the higher level may initiate with a lower level. So isolation can be a logical or physical. So logical isolation, the VLANs require the use of classified label on a data and packet, which must be respected and enforced by a network management OS and applications. A physical isolation require implementing network segment or air gaps between networks of the different security level. So normally the physical segment occurs with no link or established between network. This is also known as an air gap. So if there are no cables and no wireless connection between two networks, then a physical network segmentations isolation has been achieved. So this is the most reliable means prohibited unwanted transfers of data. However, this configuration is also most inconvenient for the rare event where communications are desired or necessary. Logical VLAN. A logical VLAN is a hardware exposed network segmentation created by switches. By default, all ports on a switch are part of VLAN 1, but as the switch administrator changes the VLAN assignment on a port by port basis, various ports can be grouped together and keep distinct from other VLAN port designation. So VLANs are used to traffic management. Communication between ports with the same VLAN occurs without hindrance, but communication between VLANs require routing functions, which can be provided either by an external routers or by the switch internal software. So VLANs are treated like a subnet but are not subnets. VLANs are created by switches, subnets are created by IP address and subnet mask assignments. So VLAN management is the use of VLAN to control traffic for security or performance reasons. VLANs can be used to isolate the traffic between the network segment. So this can be accomplished by not defining a route between different VLANs or specific a deny filter between certain VLANs. Any network segment that doesn't need to communicate with another in order to accomplish what task functions shouldn't be able to do so. Use VLANs to allow what is necessary and deny anything that is not necessary. Remember, deny by default, allow by exception is not a guideline just for firewall rules, but for security in general. A VLAN consists of network divisions that are logically created out of a physical network. They are often created using switch, as you can see in the picture right side. So basically the port on the switch are numbered. So each port is assigned the designations VLAN 1 by the default 1. Though the switch management interface, the device administrator can assign port other designations such as VLAN 2 or VLAN 3 in order to create additional virtual network. So virtualizations. A virtualization technology is used to host one or more OS in memory of a single host computer. This mechanism allows virtual any OS to operate or any hardware. It also lets computer OS work simultaneously on the same hardware. Common example includes VMware, Microsoft Virtual PCs or Hyper-V, VirtualBox, and Apple's Parallels. So virtualizations offer several benefits such as the ability to launch individual instances of a servers or services as needed, real-time scalabilities, and the ability to run exact OS versions required for an applications. Virtualization servers and services indistinguishable from traditional servers and service from users' perspective. Additionally, recovery from damage, crashes, or corrupted virtual systems is often quick. You simply replace the virtual system's main hardware drive files with a clean backup versions and then relaunch the affected virtual system. Then air gap. An air gap is another term for physical network segmentations, as discussed in the earlier section. Physical. So next we go. So VLAN, so you can see the VLAN v2. So the previous slide, so I don't have the space, that's why I put it on a different slide. So the VPN tunneling, a private network connection through an unsecured or public networks used to connect LANs. Remote devices appear as they are local methods, site to site, remote access, and RAS. A VPN is a virtual private network, is a communication tunnel between two entities across an intermediary network. In the most case, the intermediary network is an untrusted network such as the internet, and therefore the communication tunnel is usually encrypted. So numerous scenario lend themselves to deployment of VPN. For example, VPNs can be used to connect to networks across the internet. For example, you can see in the picture, to allow distant client to connect into a office LAN across the internet. So once a VPN link is established, the network connectivity for the VPN client is exactly the same as a LAN connected by a cable connections. The only difference between the direct LAN cable and the VPN link is speed. So you can see here the first picture. You can see the first right side here, the two LANs being connected using a VPN across the internet. Then the second picture is a client connecting to a network via VPN across the network. So this is give you a clear idea where the VPN placed in the corporate network. So the VPN offers an excellent solutions for a remote users to access resource on a corporate LAN. So there are a few advantage, I would say. So they eliminate the need for expensive dial-up modem banks, including landline and ISDN. So they do obey the long distance toll charges. They allow a user anywhere in the world within the internet connection to establish a VPN link with the office network. They provide security for both authentications and data transmissions. Sometimes the VPN protocol are called tunneling protocol. This naming conventions is designed to focus attentions on the tunneling capabilities of VPNs. VPNs work through a process called encapsulations. A data is transmitted from one system to another across a VPN link. That normal LAN TCP/IP traffic is encapsulated in the VPN protocol. The VPN protocol acts like a security envelope that provides special delivery capabilities as well as a security mechanism. When firewalls, intrusion detection systems, antivirus scanners, or other packet filters and monitor security mechanisms are used, you must realize that the data payload of a VPN traffic won't be viewable, accessible, or scannable, or filterable because it is encrypted. Thus, in order for these security mechanisms to function against VPN transported data, they must be placed outside of the VPN tunnel to act on the data after it has been encrypted and returned back to the normal LAN traffic. So VPN provides the few critical functions. One is access control, restrict user from accessing resource on a network. Authentications provides the identity of your communication partners. Confidentiality prevents unauthorized disclosure of a secure data. Data integrity prevents unwanted change of the data while in transit. And then point-to-point protocol, and then layer 2 tunneling protocols, and open VPN protocol, and then meaning SSL, TLS, and then internet protocol security, IPsec. So there's a lot of feature chap. You can also Google it to know more about this. You get a clear idea about this. So okay, move on next. SDN. The SDN is the entire network is virtualized. Allow for easier network segmentations. Allow administrators to place virtualized security device anywhere. So the concept of OS virtualizations has given rise to other virtualization topics such as virtualized networks. A virtualized network to network virtualization is the combination of hardware and software network components into a single integrated entity. The resulting systems allow for software control over all network functions, management, traffic shaping, address assignments, and so on. A single management console or interface can be used to oversee every aspect of the network. A task that required physical presence at each hardware components in the past Virtualized networks have become a popular means of infrastructure deployment and management by corporations worldwide. They allow organizations to implement or adapt other interesting network solutions, include software-defined network. SDN is a unique approach to network operations, designs, and management. The concept is based on the theory that the complexity of traditional network with the one device configurations often force an organization to stick with the single device vendor such as Cisco, and the limit the flexibility of the network to adapt to change physical and business conditions. SDN aims at separating the infrastructure layer from the control layer. Furthermore, this also negates the need for the traditional networking concept of IP address, subnets, routings, the like to be programmed into or deciphered by hosted applications. SDN offers a new network design that is directly programmable from a central locations, is flexible, is vendor neutral, and is based on open standards. Using SDN frees an organization from having to purchase device from a single vendor. It instead allows organizations to mix and match hardware as needed, such as to select the most cost-effective, highest throughput rated devices regardless of vendor. These configurations and management of the hardware are then controlled through a centralized management interface. In addition, the settings applied to the hardware can be changed and adjusted dynamically as needed. So another way of thinking about SDN is the different that is effectively network virtualization. It allows data transmission paths, communication decisions tree, and flow control to be virtualized in the SDN control layer rather than being handled on the hardware on paired device basis. And the picture you can see right side is a brief. It's a very, if you see this, you will get a clear idea about this. So we will move on the next topic. Honeypots, Honeynets. System or network exposed to the capture malicious activities or gathering investigations evidence and study attack strategy. So Honeynets consist of two or more networked honeypots used in tandem to monitor or recreate larger, more diverse network arrangement. Often this Honeynets facilitates IDS deployment for the purpose of detecting and catching both internal and external attacker. So you can find more information in the link, the separated from the any business network, the link you can find there, so you'll get more idea about that. So, exam preparations. Alice is a CISO for financial institutions. She wants to use a device that intentionally broken to catch and log potential attack. Answer: A. Honeypot. Answer is honeypot. The second one's Alice hired you as her network architect. She wants a file transfer servers in an area that accessible from both the internet and to internal users. What is your best approach? Answer: D. Place the server in a DMZ. Answer is place the server in a DMZ. So that's it guys for this video. So we will see more topics or more labs in the later on video. Please subscribe my channel, press the bell button to get more update. Please share the video if you like. Thank you so much. Have a good day. Bye bye.